very last bit, I promise you, and that's you're going to need to do some sums. So here are some example sums. By all means, pause the video and have a go at it yourself. How many moles in 54 grams of water? Well, first of all, we need to know what the MR of water is. So MR H2O equals 1 plus 1 plus 16, 18. Okay, so how many 18s go into 54? 54 divided by 18. Let's do it on the calculator. 54 divided by 18 is equal to 3. So our answer is 3 moles. Don't forget, chemists really like to write things as easily as possible. We write mole instead of moles because, you know, there's extra 2 letters. Who wants to write that? How many moles in 53.4 grams of aluminium trichloride? You might remember that from earlier. So, aluminium trichloride is 27 plus 3 lots of 35.5. Look the numbers up on your periodic table if you don't believe me. Which gives us 133.5. So, MR equals 133.5. Okay, and I have got 53.4 grams. To find out how many moles I've got, it's mass over MR. So I've got 53.4 divided by 133.5. And that's not right, because that's my MR, so it should be the other way around. Hang on a second, Samuel, stop the video. No, it is right. Sorry, I missed the times 10 to the minus 1. I thought that was times 10 to the 1. So it's 0.4 moles. Okay. If you remember last time, we had 2 lots of aluminium trichloride, which is why we ended up with 0.2. But this one's to find the actual moles, which is 0.4. How many molecules in 9 grams of water? Okay, so we know the MR is 18, and it's mass over MR, so it's 9 over 18, which is 0.5 moles. But we want to know molecules, so here we go. Here's my mole number. Avogadro's constant, so I'm going to have to times that by 6.02 times 10 to the 23 to get me 3.01 times 10 to the 23 molecules. Okay, and they can ask you that about atoms, or they could say, I've got 3.01 times 10 to the 23 molecules of water. How many grams would that be? And you'd have to do, oh, well, that's half of Avogadro's number, so it would be mass is MR times moles, so 18 times 0.5 would give me 9 grams. You can work it either way. Happy days. Right, the other thing you need to know how to do, balancing equations with moles. And that doesn't mean using moles instead of Lego, which would be kind of fun. I'm now picturing the sorts of videos I could do if I was good at video editing, with doing little mole faces instead of Lego, but I'm not going to do that. So here we go. I've got 3.2 grams of methane, and it reacts with 6.4 grams of oxygen to make carbon dioxide and water. Deduce a balanced equation for the reaction. Right, so the first thing I'm always going to do is I've got methane and I've got oxygen, and I'm going to make carbon dioxide and water. Now, the easiest thing in the world, wouldn't it? It would be to just balance it. 1 carbon, 1 carbon, 4 hydrogens. Oh, put a 2 there. That gives me 4 oxygens. And there you go, I put a 2 there. Bam. But no, I've got to deduce my balanced equation. Right, well, let's put in the mass first. So I know I've got 3.2 grams and I know I've got 6.4 grams. What are my MRs? 12 plus 1 plus 1 plus 1 plus 1 is 16. And oxygen O2, 16 plus 16 is 32. Okay, so I can do my moles, which is mass over Mr. Remember, it's always mass over Mr. Mole. So 3.2 divided by 16 gives me 0.2. 6.4 divided by 32 gives me, that's not correct. That shouldn't be 0.2. Right. Okay, and that's what happens when you try to write a question without checking it first. So I've got 12.8 grams of oxygen. So 12.8 grams divided by 32 gives me 0.4. So now I need to divide it by the smallest. You're quite correct. We have to do this in another sum. If you're ever stuck, just divide it by the smallest. Then might be worth a mark in that. So divide it by 0.2. 0.2 divided by 0.2 gives you 1. 0.4 divided by 0.2 gives you 2. So therefore, that means my balanced equation must be, let's grab a pencil. So my balanced equation must be 1. I don't write that in. I can be nice and lazy. And 2. Okay, so we've deduced the first part of the balanced equation. We now can't change our reactant side, okay, but we can change our product side, and we're going to go CO2. Right, well, 1 carbon, 1 carbon, we're absolutely fine and dandy. 4 hydrogens, 2 hydrogens, I must need 2 of them. Do it with dots or Lego. It really doesn't matter. Just because you're doing higher tier doesn't mean that you don't have to use the Lego. I still do it for A-level questions. So let's see if that balances. We've got 2 O2s there. 1, 2, 3, 4 there. Bam, balanced. What I would now like you to do is you've got the online textbook. If there's any of this that you didn't understand, let me know, but have a go at some of the questions in the textbook. I will be setting you them on the online learning as well, so it's not like, oh yeah, just go do the textbook. Have a go at it. Let me know where there are any problems and if you need any help, and yeah, just enjoy the chemistry. Take care and see you soon.